everyone, we're Team JBean and we researched the rutile phase of titanium dioxide for our exotic phase project. We started our research with the bonding of the elements in rutile. To determine the bonding, we first had to look at electronegativity. For titanium dioxide, the bonding that holds each molecule together is ionic because titanium dioxide is composed of a metal and a nonmetal, and oxygen has a much higher electronegativity than titanium. Since the bonds are ionic, they have a high interatomic potential energy. We see this by looking at the interatomic potential curve. The deeper the curve, the more energy is required to break the bonds formed, which coincides with the bonds formed in rutile. The rutile phase of titanium dioxide has a strong bond that is due to the interatomic ionic bonding and the structure of the material in the rutile phase, which will be discussed next. The structure of the rutile phase of titanium dioxide is body-centered tetragonal. Rutile has no parent phase and has many commercial uses due to its interesting structure. Using the equation to find the number of atoms in a unit cell of material, we found that rutile has 6 1/3 atoms per unit cell. Additionally, rutile is composed of 40.07% oxygen and 59.93% titanium. Rutile has higher stability and slightly better whitening abilities when compared to the other phases of titanium dioxide, anatase, and brookite. This is due to rutile's high refractive index. Due to its high refractive index, rutile is used in almost all sunscreens because it absorbs the majority of UV radiation. Next, we're going to discuss the defects and diffusion of rutile. The defects of rutile that have been discussed in class are vacancies and metal interstitials. Other defects include bridging hydroxyls and pairs of bridging hydroxyls. The two main defects that are very important to rutile are oxygen vacancies and titanium interstitials. Oxygen vacancies are important to reactivity, and titanium atoms diffuse into the surface. Combined, they modify the electronic structure and act as direct absorption sites. It also makes rutile useful as a white pigment in paint, food coloring, and cosmetics, as it can absorb other colors. Lastly, we researched the phase diagram titanium dioxide. There are 3 common phases of titanium dioxide, which are rutile, anatase, and brookite. When taking a look at the 2 phase diagrams drawn, it can be shown that the rutile phase can be produced from heating the anatase and brookite phase to higher temperatures. Similarly, if you take the orthorhombic form of the TiO2 phase to higher temperatures, the titanium dioxide will convert to the rutile phase. Nanoscale particles of this phase are transparent to visible light and are highly effective in absorbing UV rays. When a combination of the rutile and anatase phases are made into a powder form, they produce a white pigment that is commonly used in most white paints, paper, foods, and other items that require a white coloring. Thank you so much for watching.